I'd like to welcome everybody for joining us today on our webinar titled Leveraging AI and Life Science to Gain Insight into Your Unstructured Repositories in Minutes. We're very excited to have you all join today. We got quite a crowd. We're going to be diving in. Not going to bore you too much in slides. We will have a few, literally 4. If you have any questions during the webinar, please use the Q&A button at the bottom of your webinar viewer and ask those questions. Just type them in. That being said, let's go ahead and dive right in. My name is Brian Reynolds, and I am the CEO and founder of Doxonomy. I've got a lot of years of experience in this space, so just to kind of set that up, this is not my first go around. This is my second company. The first company I had ran that business for about 13 years and sold it to EMC Documentum at the time. What we were focused on in that space was the implementation and deployment of solutions in the unstructured data management space. So if you think about content management, Documentum, SharePoint, FileNet, systems like that, we've got years of experience doing those types of implementations, have done hundreds of projects regarding those types of technologies. Doxonomy as itself, though, was set up and started to solve a problem that we saw. After I stayed on with EMC for a while, I just saw a major problem in that search and the ability to gain insight to unstructured data has always been kind of an afterthought and not really dealt with the way that we think it should be. So here at Doxonomy, what we're all about is we're a company of people who love to solve problems. Now, when it comes to artificial intelligence and machine learning, I think there are a lot of misconceptions in the industry, especially in the life sciences industry. And those conceptions really kind of flow out as it being very complicated. I've attended as well as spoken at many different conferences, and it's really clear to me that there is a tremendous amount of interest in this technology. People want to use it. But unfortunately, many of the solutions that we see out there are just very complicated, or they're very expensive, or they might require you to move all of your data into their system. And we just find that that is not the way things should work. It really shouldn't be that hard. We think that it should be very simple and very easy to take advantage of this technology if you approach it in the right way. When you think about the public domain every day, we think about Google. We Google our information all the time. I mean, obviously right now we're Googling about the news and sort of the craziness that we're living in this world. We Google the weather, we Google scores in the games, although not so much right now. But we get instant answers and it comes back immediate. When we go behind the firewall and we start to deal with our company information that's out there, we find that that experience is not anything remotely close to the same. It's very painful, and it can take days and weeks and months, projects basically, to extract any kind of meaning from content. And even at that, it's very hard to deal with the fact that you have hundreds, dozens, whatever, repositories with millions of documents across them. It's a huge task to undergo. However, with Doxonomy, we've developed a solution and a way to do this, a platform that makes it very simple, and we've made that easy for you, and that's what we're going to be showing you today. So this is my last slide, but it tells a true story. And what I want to do is sort of articulate within this slide the power of what we've done in a simplistic way. So companies like all of you that are on this webinar have numerous repositories in all varying kinds of different technologies. You have spent countless millions or billions of dollars developing business processes on top of these applications that many of the people in your organization use on an everyday basis. And they interact with that data, and they run the business on top of that data. Unfortunately, most of these solutions don't really communicate with each other. They don't talk to each other. You might get some variations of that, but it's not clean. It's hard enough just to search in any one of these technologies on top of it. If you don't know the exact metadata or know exactly uh, how something was labeled or what it was named or something to that effect, it's very hard to find what you're looking for. So, what we've heard over and over from our customers is that, you know, they have this information, but they just can't find it. They know it's out there, but they just don't remember where it was stored or when it was stored. Maybe you acquired systems through an M&A activity, and you're not real familiar with, you know, the stores that you inherited. These are things that are just common problems. What we've done with Doxonomy, and what's important about this slide, is we've been able to use our pre-built crawlers that are very easy to just configure and set up. They require zero code, really zero effort, to intelligently crawl these repositories and extract insight or build an index from the data that's there without actually having to move the data. There's no reason to actually migrate that data to the Doxonomy repository. It's really just an index with a pointer back to all of these various different source systems. So you think about all these various different systems that you're using, whether it's Viva or SharePoint or Documentum or whatever it may be, you can index all of the documents that exist in these data repositories. And we do databases as well, structured data, and aggregate that data to one centralized index for two things: to search and to gain insight. And you can do all of this, you can gain this intelligence without any migration. And that's what we're really all about. Now, some of the features and functions that we have, we're going to get into. So let's go ahead, and I'm going to switch over right now and get right into the demo. Okay, great. Now that we've transitioned over to our demo screen, let's go ahead and log into Doxonomy. So I'll go ahead and use my username and my password, and I'll go ahead and get logged in here. As you can see, when you first come into Doxonomy, that sort of Google-like experience that we talk about, you know, the ability to Google the information, is the same experience that we want you to have in our application. It's easy to use, every user understands it, and that's exactly what we want to do. So let's start out right away with just a quick search, something very simplistic. Let's take a use case I've heard a while in conversations with customers. So in this case, I've got a whole series of labels, let's assume, out there in various different repositories, and I need to identify and look for labels that have to do with glutenal intramuscular injection. I know they're out there, but they're stored as images. So how would you search that in any traditional type system? Well, it'd be pretty painful. You'd have to kind of look for it. In our system, it's very easy. So we're going to go ahead and insert the phrase. So I'll put it in quotes because I want to search as a phrase. I want to do an image search in this case, and I'm going to go ahead and search. As you can see, very quickly returned are 3 images for the images that I have. And these are all JPEG images. Okay, so these are actually stored somewhere out in various different locations. So if I actually open this up and take a look at this one, let's say this is the one that looks interesting to me, I can see that this JPEG image has been brought back because everything that goes through our system, whether it's an image sitting inside of a file share somewhere, or images that maybe are embedded in documents, which in this case this is, and I'll show that in a second, we OCR those images and give you the ability to search across them. So we can see here our hit, you know, gluteal intramuscular injection was a value that was brought back. So again, leveraging AI, leveraging machine learning, leveraging OCR, leveraging these sort of powerful abilities, we're able to identify and extract meaning from things that normally you wouldn't get meaning from. Now this image actually is sitting inside of a document. It wasn't sitting out by itself, and that document was a PDF document that was actually stored on the system. So we literally crawled over that document and identified this image inside of that document, pulled it out as a child within a relationship of the parent, and processed the OCR on it so that you could search for it and find it this way. So that's the depth in which we crawl across content and index that data. We look at it very deep. We don't just grab the text that's right off the top. We literally analyze everything that's embedded inside of it that we can get at, and apply our AI and our machine learning models to it to extract insight out of it and make that available. Now, let's say, for instance, that we want to do a deeper search on this because this phrase that we see right here is of interest to us. So we actually want to search everywhere within the repository right from this result that we found where the whole phrase for deltoid or gluteal intramuscular injection only. We want to look for everywhere where that's mentioned. So we can highlight the phrase and right mouse click and literally click find similar. As you can see here, we get a result back of all the different locations where this phrase is used with a similarity score, giving us a sense of how similar the phrase actually is. We can also see from a source standpoint that it's looking across multiple different repositories. So in our demo environment, we've got a file share and Documentum, and then regular doxonomy that it's directly in our system and so forth. But different classification types of documents that it found it in, which we'll talk more about. But most importantly here, we see one that's 100% matched to the phrase that we found in there that we were looking for. And we can see here, let's go ahead and jump to this document. As this is returned, we can see that the document viewer is opened up. We can see it's highlighted here where we actually were looking for that particular sentence or that phrase. And you can also see the original child image over here that we started the whole search for. These are the children of that parent document that we had pulled out and indexed and had found. Again, from an intelligence standpoint, this is very powerful. You can actually see that the AI that we're utilizing inside that is actually going in and doing that deep analysis at a vector level of every phrase, every sentence, every paragraph, every document, and it's bringing back that similarity and allowing you to very easily be able to find this. The power of all this requires no human involvement. This is just part of the application and how it works. As we continue on here in this document a little bit further, we can actually see a few other attributes on the screen. So one in particular is intelligence over here. So we automatically identify and extract any of the meta information that is stored on the document, whether that comes from Documentum or SharePoint or whatever the case may be. That information would be extracted from the source system and would be available within the index. But there's also discovered metadata or discovered data entities, we call them. We can see, for instance, here there's pharmaceutical names and side effects and countries and so forth that have been pulled directly from the text, not actually entered from a human being. Let's say, for instance, intramuscular was something that we were interested in. So let's take a look at that. We'll see that we found intramuscular within this document. It wasn't metadata that was provided. And we can highlight that and quickly jump to all the entries of it. There are 8 of them within here. And we can see that that is the route of administration. It's intramuscular. So that's very powerful in that we've able to identify that. And these are all attributes that are extracted from the artificial intelligence and the machine learning algorithms that are built into the core platform. There's also that same similarity across documents. So because we're looking at this particular drug and we're looking at the medication guide at this point, we also know, because of how we searched and how we came at this document, these are other drugs or other labels that we identified and found in the system contextually that are similar. Okay, so they're within a common threshold that's set at the source system to say these are similar in content to what you're currently looking at. So you're probably interested in these as well. And of course, we could click on any one of these and launch them and open them up. Now, if the system is set up properly, however you want, but if it's set up properly, there can be a PDF rendition of the original source content. So while we view this in a textual viewer for rapid and fast interaction and doing highlighting and all of that, we can click the view button here. And as you can see, we can launch the original PDF document or a rendition if it happened to be Word or something else, but a PDF rendition of that document. We've looked at a lot of different things, but let's go in and let's do some additional searches because we're short on time, and I want to show you more about the searching and more about what's going on underneath the covers. So let's click on search here. So let's do a slightly different image search now, just to kind of show the power of the AI that's underneath this and what's happening. So we've got a use case here. Let's say there's a promotional marketing video that you need regarding a particular product. You don't remember where it was stored. You don't really have any keywords to go off of. The only thing that you can remember in your mind is that there was a scene in it that had to do with golf, somebody playing golf, and that's all you can really remember. So in a traditional system, that would be near impossible to try and find other than just browsing and looking and sorting. But in the Doxonomy platform, it's actually very easy to find. So let's go with what we have. We're going to type in golf, and we're going to do an image search. And what we'll see right quickly is that we get back a series of results of some images of somebody playing golf. So let's go ahead and click on this and take a look at what this is all about. So there's no text on this. This has nothing to do with text. What you'll see is the power of our system is that we analyze every single image that comes through our index, and we try to predict using our AI model as to what is in that scene, what's going on inside of that picture. So you can see here, these are the attributes that we've tagged it with, and you can see our accuracy. So we're 99.8% sure that this scene has to do with golf. There's a golfer, golf equipment, and so on. And you can see those predictions that we're making there against this. So the power of this is that this allows us to be able to get at and find something that you traditionally wouldn't normally be able to find. And that's the simplicity of the AI. This doesn't require any person having to put anything in. It was derived by the system out of the box. Now, if we open this up and take a look at it, we'll see that it's tied to a parent. It's a child of a parent. So let's go ahead and open up that parent. And what we'll see here is that this is a video. So this was a scene in a video. So you can see over here on the right-hand side, we analyze all the frames within a video and we pick out the unique differences between them. And then we make that same prediction. That all becomes part of the index. It all becomes something that's searchable now on top of this video, as well as the transcription of what's being said in the video. If we have a transcription, we'll import that, we'll bring that in. If there isn't one, part of the metadata, then we'll automatically try to transcribe it ourselves, and it's pretty accurate. We'll go through and we'll derive that, and all that becomes searchable and indexable so that you can query for that. And the same thing's true. We're looking at a video, we have it opened up based on the segments, based on the meta information that was derived from the AI. We can make that same recommendation of other documents, other videos, other things that exist in the system that are very similar contextually. And this is all part of the power of that deep crawling and that deep analysis that's being done by the tool. All this out of the box. And that's the beauty of it. So let's move on and let's kind of do a slightly different type of search now. Let's get into some textual based searching. So let's search on duoplavin marketing authorizations. So I'm just doing some keyword query searching here. Let's go ahead and execute that. So we get back a series of results that come back with various different information. I'm going to dive right into this first one because I want to take a look at what's going on inside of this. So what we have here, as we saw before, is a document that's been returned to us by this search for the authorization request for marketing. as we can see here is what's highlighted. A couple things that I want to note on this real quick. One is the power of deduplication within your repositories. As we can see, this came from a file share in our source repository, but we'll notice up here that we see there's one duplicate. And we can open this up and we identify and we'll list everywhere where this document is duplicated. We can also see that it came in from our SharePoint crawler as well. Now, we don't store the document or index it multiple times. We do specialized deduplication. We only store it once, we only process it once, and we keep track of all the different locations where it is duplicated. But the power of the system is that we can very quickly find all your duplicate documents throughout the repository. Another really kind of neat aspect of the system is this document came back to me, and I can view through the text here and I can see it. But the power of this is that on the fly, I can go ahead and translate this document. So let's say, for instance, I want to view this document in Japanese. I can literally go in and translate it on the fly into Japanese. And we'll do the best that we can with our translation. But out of the box, we can support your translations as well. So if you already have translations, we can support those as well. But we do translation into 104 different languages. What's another sort of neat aspect of this is this document, when it came into our repository to be processed in the first place, if we look at the PDF rendition, is it was originally stored in French. So we take the French document, we automatically translate it, we process it and analyze it with our AI tools to extract natural language out of it, doing natural language processing. And then, of course, we give you the ability to translate that on the fly. Now, none of these documents were affected in the source again. This doesn't require any effort on you or the user's part. It's just how we do searches. We can also execute searches in native language as well and return results. So if you're looking for something and you want to write that query in Japanese, you can do that and you'll get your results back the same as you would if you write it in English. So another very powerful aspect of the tool. Let's move on to another search right now that I think will be very interesting as well. So in this search, we're going to search on lorcatin potassium, and we're going to go ahead and execute that query. So we get a bunch of documents back, and what's interesting on this, and we've seen this is across everything, is the ability to extract the insight or facets, if you will, entities from the content. Using natural language processing and the AI engine behind the scenes, we automatically extract this. And that comes in the form of facets, very similar to what we would see if we were shopping, say, on Amazon for something. But in this case, it's related to the content and the context and what we've extracted. So let's say, for instance, we want to filter on pregnancy, and we're looking to filter this further down, say by route of administration for intramuscular. And we can very quickly see how we can fine-tune our document results down to something that's meaningful. But more importantly, let's kind of clear this and sort of look beyond that. So by having the ability to grab that data and extract it and apply that insight that you haven't had before against these unstructured repositories, we can actually toggle into an insights view and begin to visualize these search results in a purely data-centric way. Now this is very powerful, very unique to our application. This is built right in. These are configurable and defined, and we'll even go deeper into this in just a couple of minutes from now. But let's take a look at this right here. So we can see the top 10 in this case, or top results that I was bringing back across in a visual standpoint from the data that was returned. And all of this is purely filterable, I should say. So if you wanted to go back and say, go to that same Route of administration, maybe we want to limit that to be intramuscular. We can, fine tune that down. We can see our data's changed, and we say, oh, well, this Gardasil is what we wanted. We can actually click on that, and it will do another search, which again can be fully visualized. We've actually done another search, and if we want to, we can toggle back to the list, and we can also see, the search results back in this document-centric format. So all of that built right in to the tool and available day one when you start using this application. So let's go on and do one more search, and then we're going to look at some dashboard capability. Now, the power of the search within Google in our everyday life is about asking questions. And when we ask a question, we get an answer back. It's not always just a search result. Well, the power of Doxonomy takes the ability to do that and applies it to your own data. This is a powerful aspect. So let's ask a simple question here. Who notified about withdrawal of duvoplavin, right? So we're going to go ahead and ask that question. As you can see, the system has actually been able to answer that question, that it was Sanofi Pharma, Bristol Myers Squibb officially notified the committee. And that was basically an answer that was derived from the data set that we have for the demo purposes. Now, the power of the engine is that it understands what we call question and answering. So if you ask it a question, who, what, when, how, where, things like that, the system is going to try to answer your question based on the data that you've indexed and crawled. So the more information that you crawl, the more robust the capability is to answer questions. So it's not just keyword searching, it's not just the entity searching, it's not just the ability to search across the data, but it's across the intelligence that exists within the data through the AI mechanisms to be able to answer those questions. And that's a very powerful aspect of a system that requires little to no effort to get up and running. Because the crawlers are pre-built, because we have the capability to deploy this into any environment that you want it to run in, whether it's AWS or Azure or Google Cloud, or if you want to run it in your own data center in a virtual environment, we deploy as a virtual appliance. So it's not an installation, it's just drop into place. The configuration of the crawlers to be able to point them to the different repositories are all pre-built, so you can point these. So you can literally in minutes, as we had said in the webinar, less than an hour, have the whole system up and running and crawling and begin to utilize it day one without any costly migration, without a large project. It's very, very powerful and easy to use. Now, I did promise one last thing, and that was in respect to what we could do when we aggregate all this data and how we can visualize that data. So let me switch over to a different screen here and take a look at dashboards. Hold on. Okay, so now we're on a completely different screen. In this case, it's a dashboarding screen. So we talk about how we analyze that data and how we have extracted all this insight using AI and machine learning. And it's really about the ability to visualize that data, not in a document sense, but in a data sense. So let me go ahead and open up our life science dashboard here. So we're using Kibana here. So the open source tool for doing dashboarding and analyzing data. Our data set is designed to work with this, but it also will work with Tableau or Spotfire if you use those. Any of these other BI tools that exist out there, you can point it to our data set. We have ways of being able to do that. So what you get here is a visualization of the actual data, and this is very powerful. So this is a quick dashboard that I put together for purposes of this demo. You can see here that we're looking across different sources for different, custom entity types. We can see sort of the count of those various different types. We've got a tag cloud down here that's kind of showing all of the different values, the data that's coming back and what we've discovered, and a list of top documents, the top 10 or 20 documents that are coming back that are relevant, and you can see across the different repositories they're in and the counts and so forth. So the power of the dashboarding is that I can slice and dice my data. So let's say, for instance, I'm only interested in side effects, and I want to analyze that. So I can click on this and I can immediately reslice all my data, and now I'm only looking at that particular slice. So side effects across these different source repositories that we crawled, SharePoint, Documentum, the file share directly in Doxonomy. The tag cloud changes to just side effects that were found, and we can see it's bubbling up like the most important side effect across the data that we crawled in our sample set. The documents that are the top documents that are affected by that. Now, if we wanted to, we could say, well, this myalgia is the top one, so let me click on that. So I can click on that and again further drive in my data to just that and documents that exist down here. Now, this is a very simple and easy dashboard that I created, and you can get as deep and as much as you want. But the key here is that because of what Doxonomy has done up front, you can do this now with this unstructured data source, and it's actually rather easy. So I'll just jump over here real quick into Visualize and just sort of show you. So let's create a new visualization, real simple. I'll use a lens in this case, and it's all drag and drop. So let's say, for instance, I want to look at file extensions, okay, and I want to look across my meta type or my entity types. So I'm going to go ahead and slice that, and I want to go ahead and group by that. So boom, by quickly just being able to drag and drop these data values against all that information that I've crawled already across these different repositories, I now have built a visualization. And of course you can fine tune this and filter it and do all kinds of really cool things, but this is the power of what we're able to do. Now, I hope you like that. I hope you like everything that you've seen. We're at the end of our time here, so it's a lot to cover. There's a lot that we didn't cover, and there's so much more that we could talk about. I thank you all for joining us. What we're going to do, as I said before, is we'll make this video available to everybody that was on here. We'll follow up with you to answer any questions. Hopefully we answered any questions that you had along the way. If we didn't, we will send an email out with those questions answered, and we'll look to schedule a time with you to do a deeper dive around your use cases and your needs. But I hope that you saw the power of Doxonomy and what we're able to do and how easy it is to apply AI and machine learning if you have the right platform. Thank you very much today for your time, and we look forward to talking to you in the near future. Have a great day.